Hi, everyone. Thanks for joining the November 2020 edition of the Adaptive Cards Community Call. We're almost at 2 full years of this call running, which still just blows my mind. I can still remember when Dana sent us the request, like, hey, do you want to do this thing? Today, I was just joking that I am like the teacher who comes in the day and they wheel in, for those of you that are, 90s babies that wheeled in with the TV cart and said, we're going to watch a documentary today. So I don't have anything to do today. I am going to hand this off to our friends from Imaginea, Vasanth, Haridas, and a handful of people who have been working on a feature that we were really hoping to roll out to production today, but we hit some accessibility stuff that we didn't catch with high contrast mode. So they're going to demo it, and I just want to reiterate very clearly that this will be available on adaptivecards.io very soon, probably next week. The final test pass with accessibility is being done right now. So the feature works. It works great. We just want to make sure it works great for everyone, including low vision people. So that's kind of the last piece. So they're going to show you what that feature even is. Quick summary is it's Pick-to-Card is kind of the catchy name, but it is a really cool addition for people who already have design skills, or they've designed a card in a graphical program and they've got a bitmap of their card, and you can feed it through this this tool that they've built, and it will output an adaptive card based on that image. So hopefully that whets your appetite a little bit. It's a really neat feature that we're going to bring out to everybody very soon. So thanks you guys for coming in and talking about it. And with that, I will feel free to take over sharing the screen and kick it off.
Thanks, Matt. Quick introduction. I'm Vasanth. I'm from Imaginea Technology. I head the engineering part, engineering director. And I have my colleagues, my fellow folks, Haritas and then Keetana joining me for this presentation. Let me quickly share the screen, and then we are good to start from there. Okay, so the agenda for the call is pretty much like explaining about the Pick-to-Card, how it helps the adaptive card community, how it helps basically the adaptive card. We'll show you a quick demo. We want to start with the demo, but we'll give a quick intro and then start with the demo, and then we'll deep dive about how we did, what we did, and then we are happy to take a question at the end. So I want to start the day with a thought for an idea. Okay, so usually when people used to say, right, when you have time, do it yourself, right? That's a great way of doing it. But if you want to do it faster, probably you need to get it done by others, right? So if you want to do everything, you cannot do it faster because you are going to take your own time. So if you want to do it faster, do it from the other. But you want to do it fastest by all means. Just leave it to the computer, right? Leave it to the machine. That is the whole world is driving towards that. That is the reason why the world has taken that. As of today, if you see it, the whole world is taking a step for a AF first approach, right? So we are also taking an AF first approach to create an adaptive card. So I just want to throw this idea to everybody. Just this is the inspiration for us to start it. Okay.
Yeah, I like that expression.
Fastest, and then we left it to the machine. So we'll see how the machine does the things, and then we'll go from there. So the adaptive card platform, we know about, like, it is a platform and a snippet for UI. In a simple word, UI as a code, which is exchangeable, and then it renders natively in all the platform. Works across all the class platform. It can work in mobile, it can work in browser, it can work in Windows, Mac. All, if you name it, it has the render for it. Right? It also provides a beautiful designer interface. It looks fabulous, and it is easier, and then you can easily design an adaptive card, right? But still, if you see it, the native designer, right? If they come and then use the adaptive card designer, there is a bit of a learning curve. They have to learn it, they have to learn the tool, they have to learn the code, how it works, and then how to set the property, and then different bindings, everything they have to learn. It is not like people will come on the day and then learn it immediately, right? There is a little bit of learning curve associated with that. And then if you are designing for the first time, you will find it bit hard to get it right. Okay, even though we have put up the designer tool is best for both designer and developer, but it will take a little bit of learning curve to learn it. So we thought, like, okay, what if we can convert the code? We can generate the code from an image. Okay, native designer, usually they design the card in their own tool, right? They go and then design the Photoshop or Sketch, or you would have seen in a beautiful card in a web, or you browse through a Google and then you found a beautiful card. You want to quickly generate an adaptive card out of it for your own use. You can definitely use using the pick to card. So here comes, what is a pick to card? Pick to card is basically you input as an image and it will generate an adaptive card. Without taking your much of expectation, let me quickly show the demo and then we'll go from there.
And I'll actually, while you're doing that, paste the URL into the chat so people can play with it. And yeah, this URL will go away soon. It'll be on adaptive cards.
Let me quickly show the demo. Okay. So as usual, you go to the adaptive card designer page. So you want to create a new card. We have put a small item here. You can create an adaptive card from an image. Okay. You can click here. So this is loading from our PR link, basically. If you see it, this is the latest PR, which will definitely in 1 or 2 days, it will hit the production. So as soon as you see here, we have given a sample cards for you guys to try out. You can try out any one of this. I'm going to try out one of this. And then I will also show you a live demo, okay, how we'll randomly pick one image and then see how it works. Okay. So let me go and then convert this image. So this is a raw PNG image. Okay, I have inputted the pick to card machine with the image, and then it is in the background. It is converting the image into a adaptive card format. Okay, so it has actually converted the whole image into an adaptive card. This is the live adaptive card. It is actionable. It is everything understood. It understood the picture. It understood the textual property. It understood that this is an action set, and then created a beautiful adaptive card for us. If you want to enhance this adaptive card, you can go and then drag new element and then start adding new things to this. Or if you are good with this, you can straight away use this in your part of your code. So you have the code snippet here. You can copy paste and then use it as an adaptive card as usual. Let's pick another example. Okay, one more example. Okay, so here we have provided an option to create template. If you see it, the adaptive card 2.0 support template binding, wherein which you can also bind your API with the adaptive card payload. Okay, so I'm going to enable this. Let's see what it does. Okay, so it has, as usual, it has generated the adaptive card, and then it has given you the code, the JSON format. It also created a sample data binding, and then if you go to the preview mode, you can see it. So all the image, all the choice set, everything has been given. So you can easily bind your API into this and then quickly create the adaptive card, which is directly plug and play into your code. So let's go and then pick some random image. Okay, I'm going to search for some adaptive card sample from the web, and then let's try it out how it behaves. Okay, so.
Yeah, I've never seen images fall into the more menu on Google before.
Yeah.
You're getting A/B tested live.
Yep. Okay. So let's take this. Okay, I'm going to save it as an image. Okay. Okay, my desktop. Okay. And then I want to pull one more image. Okay. Probably this. Okay, this looks like a good image, good candidate for this. Okay, let me save this. Okay. Okay. So I have downloaded a couple of images from the web, which I want to convert quickly into a adaptive card. Okay, let's try that, how it behaves. Okay, let me input this image. Okay. This is the image we got from the web, right? So I want to convert this as an adaptive card. Okay, with a click of a button, it has converted into a adaptive card, and then this you can go and then edit. We can definitely edit the property if you don't like the size. For example, I want to make it like a small. Okay, I can go and definitely make it as a small or medium for that sake. And then whatever we want to give, right? We can definitely alter the property from here. Okay. So yeah, let me go back to the slide, or we can see one more demo. Let's see a complex card how it does. Okay, we did download a ticket, right? Yeah, this is the ticket. It looks like this is a flight ticket of David. Okay, let's try to convert this into an adaptive card.
And Vasant, will you go into details on the image extraction at all, or that it pulls them out? Okay, or I don't want to get ahead, but it's such a cool part. I want to make sure people see that.
Okay. It is converted into adaptive card, and then we can edit, we can enhance this card from here. It will give a base ground for you to play. Instead of starting from empty card, we can definitely start from a beautiful adaptive card, which is already converted from the image, and then we can start iteratively improving this from here. Okay. So let me go back to the my slide. Okay. How did we do? Okay. How did it looks like a little magical, right? We uploaded an image, we downloaded some random image from the web, and then it magically converted into adaptive card, and then we are able to use that as adaptive card. What we are doing here, we are applying computer vision, and then to extract all the elements to understand what is the object in that particular image. Is it an image view, is it a text view, or is it a radio button, or all the elements we are extracting using the computer vision. And then we also extract the textual property. We extract the text using the OCR, and then we also have a custom heuristic to extract the property, like what is the font, what is the type of font, what is the importance of the font, is it like bold, light, medium. We extract all those properties, the color of the font, and then we extract everything from the font, and then we generate a layout. Is it a center line, is it left aligned, where is the position of that particular element appear in the card. And then finally we have written a wrapper which actually convert the entire thing and then output as a JSON, adaptive card JSON. Okay, that is what it happens in a simple step. I will call upon my colleague Haridas to give a much detailed explanation about how we do, what are the different algorithms we have used, and then even when we used for example, we have used a faster RCN, we did a comparative study. We tried at least 4 or 5 algorithms, and then we picked the best out of it. So probably we'll give some of the ideas. What are the testers we have done? What is the output and how it performs? I'll call upon Haridas to give that.
Hi, hello. So just a quick intro. Haridas. I'm a data science architect for Imaginea. So yeah, quickly we got idea of how things looks like, right? So how we did it at the under the hood. So this slide shows a high level. What are the stages involved on that, right? So here we have object detection. There is a one ML model, or we can say a deep learning model that will feed the image, and it will produce find out the important parts in the image, and then it outputs that. And we have a set of post-processing pipeline that will crunch that and extract the text, extract the font, extract the alignments. I mean, it's left to right or center, and also placing it in the right places, so that it does all that, and then export into a target format. Here it is adaptive card. So we can export that to a HTML also. That's a high level idea. So here, so if you see what's that pipeline looks, this is the we can say architecture of that pick-to-card pipeline. So it gets the image, and the model side, what actually main part is a CNN model. You can say convolution neural network. So that's generally a backbone model that will gets the image, and it creates a intermediate representation. So then from that there is a B-box prediction. Here the B-box means bounding box. So for example, in adaptive card, we have like a text box, radio button, image. It's in our case, it's an image inside image. Right? We are inputting an image, but there is an image inside. There is another image. So we have to find the image also. Action buttons. These are the different types of items or objects in the image. So this B-box prediction, what it will find is find the exact coordinates, and it finds the bounding box in that image, and it the model will gives that as output. The next stage is the based on that coordinates. I mean the bounding box position. The layout generator creates a data structure, internal data structure, maintaining this structure, so that we can that entire that information can be used for generating the adaptive card. So that's a layout generator. That's one of the core part. And the next is the each for if you're getting a text object, we have to extract the OCR. We have to OCR it, We have to find the font weight, font height. We have to find the font color, and that's a kind of general properties. And also another thing is the relative positioning, and the even the font weight and font size is a little tricky thing. We are doing a lot of iterations to get a decent level, because it involves the overall aspect ratio of the card or aspect ratio of the image. Based on that, the font may look like a bolder, but after extract it may look like lighter. So we have to take care of that. So those are the key property extraction. Then with this layout information properties, we merge it into a common data structure, then export to Adaptive Card. So that's what we were seeing it at the final. So let's look at the model side specifically a bit more. So as Vasant mentioned, we tried out a bunch of models. These are kind of state-of-the-art models available in the object detection. That's object detection, one of the like ImageNet problem. You might have heard about the ImageNet competition, right? Similar to that, object detection, it has its own benchmark. There is models are competing for a general data set. It's called a COCO. And so it's there maybe recent 3 years, 3 or 4 years, it become more become better at predicting objects or finding the bounding box of any objects if you train it. So we picked the latest 4 models. I mean, based on the benchmark, the fast RCN is the one of the pioneer, you can say. It set each one sets a sorter at particular point, state of the art at that stage. And Dictor is a recent model from Facebook. It uses the transformers, end-to-end transformer-based encoder recorder model. So I'm not going internally into the model architecture, but I'm showing these are the models used, and even a recent paper is the efficient det. So that is, it's a family of model again, 0 to 7 actually. So it works well for a particular data set, but in our case, we have to see. I'll explain that how this model perform in our case. Our case, each data set some models will behave in a different way for a particular data set. So we have to pick the best one for our scenario. Okay, so let's see the performance of these models, how for our data set, how these models performed. So this is the metric. Here also we are using the common standard metric that used by the benchmark. I mean publicly available open source benchmark. These are if you are not aware of this AP50, that's okay. It's an object detection standard conventions. So using that, these numbers we got from our data set. It's like we have maybe assume like 200 images, and from that we will train using maybe 150 images. We will train it. 50 images we keep it aside, and so after training we will feed this 50 images and check the metric. We will evaluate the model performance. How for these 50 images, generally it is called a test images. Okay, so these metrics are from the test image. From this, you can see that the highest is the better here. So the fast RCN still performing better. Even actually, the fast RCN one downside generally it came maybe 3 years back, but it still performed better for certain use cases. But it is not good for a real time. If you want a low latency prediction, it is not a good for. But in our use case, latency is not a very critical thing. Main thing is accuracy is the main important thing. So we can compromise that actually. So the other recent models are tackling this problem, like reducing the latency without compromising the accuracy. So that's a recent innovation coming in this space. Okay, so the right side is the class specific accuracy, the map, and for example, the actual the AP50. Here AP means the MAP actually. It's a short representation. So here we took that just to show that each class how it performed. So the text box, how action set, how what is the numbers we got. Okay. So yeah, so this is the metrics. So we main idea I want to highlight is we are sticking to the public available metrics, that conventions, to ensure we are keeping update with what is happening in this space and following the standards. Okay.
And so this stuff was completely new to me, but I wanted to ask a quick, like, is this on the performance of like how quickly it's able to come to a sufficient result, or how accurate the result is?
Okay. Let me take that question, Matt. So when he said that it works perfect for the real time, he's referring to like you have a camera feed outside and then you want to detect something, right? That is the performance. He is talking about something like an embedded system where in which you have to detect a thief, for example, right? From the live feed, that is what he's referring. Still, the faster RCN performs good. The latency, if you see that, right? We upload that image within a couple of seconds, we are able to get the response from the backend. So the latency in our case is like maybe 3 to 4 minutes based on the model, based on the complexity of the card, also based on our network. But the ML model itself take like maybe a 3 seconds or 4 seconds time overall. So
gotcha.
For our case, faster RCN is best. But if you want to do a live thing, as I said, right, from a camera fit, then we have to try out a different ML mode.
Gotcha. Okay, that makes sense.
So it's not a latency. Latency is a different. That's based on the domain. We can pick take a latency versus accuracy compromises. So let's see our data set that what we collected for our training. So this is the we collected around 200 images. This is not a very huge amount. It's a very starting only, we can say, starting in a sense, a reasonable size only. We are not training from the scratch. Okay, so it's kind of transfer learning, called as a transfer learning. So existing object detection models we take, it's trained on a general objects, like 90 objects. 90. It includes animals, a car, a jeep, or like a 90 general objects it trained. Okay, so but here we want to detect a text box, a image inside image, or a radio button. That's the kind of requirement. So we have to we need that knowledge of the existing model, and but we feed a few more data, and we train that model to focus on our problem. So that's kind of a crooked way of saying transfer learning. Okay. So here we are using 200 images that we collected from adaptive cards and also internet. Then we labeled it. So from these numbers, you can see that there is a skewness, right? A skewness in the sense, or imbalance. So all types doesn't have equal number. That is expected, because if you take 10 cards, majority of them will be a text box, and so that distribution you can expect. So that's a real life, that is imbalance will be there. So the model has to know that to predict. In our roadmap, we want to increase the size to get the model resilience more in the real life scenarios. So that's in our that's kind of in the roadmap also. But with this itself, we are getting the prediction side decent, very good actually. We can say decent, also very good accuracy. But we can still improve on maybe the low quality images or tilted. Very poor images like that, so we can improve from this current stage also. Okay, so I want to explain about the model side and how internally what is happening in the model. So I think the next the key part is the layout. What after the model pumps the bounding boxes and the type. It says this is the coordinates of text box, and this is the type of it. It's a text box or image. That's the job of the model. After that, we have to do the remaining job. So this kind of positioning it, extracting correct things. So that's what the remaining pipeline does. So I think I'm inviting Kirtana to take from this point.
Just a quick intro. I'm Kirtana. I'm a software engineer in Imaginea for about a year and a half. The next step in our pipeline prediction flow is the card layout generation. So this is like a key stage, like Hari said, because it bridges the gap between the model predicted output to the adaptive card JSON. So basically, we can say it has been subdivided into two tasks which happens parallelly. One is the property extraction. So I'll talk about property extraction in depth. Like Hari said, the model gives only two things: the type of the elements and the spatial details. With this too, we have to extract the relevant properties of every element. For example, we can see the grand buffer spread text box on top of the image. So what are the properties related to that text box? The first thing will be extracting the text out of it. We do that using the Tesseract OCR, which gives us the bounding box values of a particular character wise also. And the next property will be the extracting color. So one of the major challenge in extracting the color was like how do we differentiate the certain color ranges inside a design area? So the approach that we used is we try to quantize the color ranges in the area to the two most dominant colors. So from the two most dominant colors, taking the least dominant color as a foreground color and take that as a text color. Okay, the next property will be like the font size and weight. Like Hari said, this is like most tricky property because its values depends upon the aspect ratio of the entire image and its aspect ratio of the particular design area. So the initial approach we used something is called edge detection and contour building. So what it basically does is like it tries to find the image level pixel intensities of each and every alphabet and tries to build a rectangle around it, we can say. And what we do is like basically take the average of the width and the heights of the bounding box, the rectangles inside the alphabets, and we can take the average of it and fit it in the font size and weight. But the main issue in this approach that we saw was what if two or more alphabets get grouped inside a edge? So that will be skewing up our font size and weight, right? So we did a couple of methods considering the height and weight ratios with respect to the design area, but that didn't work out. Right now we are using a approach called morphological approach. This approach basically does something called skeletonization of the image. So when I say skeletonization, it is nothing but drawing a outline of each and every alphabet. Consider it's like an outline is being drawn on top of the each and every alphabet. So when the outline is detected, now all we have to do is to take the ratio of the area inside the alphabet with respect to the design area. So when we take analysis of different images and bin the thresholds, we are getting some promising results right now. So that is a default approach that we use. And the next property might be like alignment. This property has a major challenging in terms of understanding how does an alignment affect the entire element's position versus how does alignment affects the arrangement of the text inside it, we can say. Maybe for example, we can see the image here under the grand buffer spread. So if I say it is center aligned, the whole image is center aligned. So what if in that place there is a text box having 3 to 4 lines of text? So when I say center aligned, it affects the property of the text content inside the element also. So we have to differentiate between these two. This was our like major challenge. Like this, we have a couple of properties for each and every element. So in this stage, the property extraction will be getting a list of design elements with its related properties extracted. So that will be in this stage. So another task happening parallelly is the layout generation part, the layout structuring part. So in this layout structuring, basically what we do is one thing, we try to group the elements into its respective containers. When I say that, we can see here we have 3 radio buttons. So the model gives us 3 radio buttons and the properties will be extracted. Right now we have to fit them into a choice set having 3 choices. So how do we group all these things together? How do we group certain elements into a column set? All this decision will be made here. And where do we fit this choice set in the design hierarchy? That is also made here. We do this with the help of the spatial details from the model. We build certain heuristics with that details and we arrange the layout structure. So this is an example of a layout skeleton. Here we can see each and every element is being represented as a set of coordinates and properties. Once we build this layout structure, the final step will be we have to map each and every element in the layout structure to its corresponding adaptive card format. So which will give us the final adaptive card JSON. So this is the end-to-end flow of how a pick to card works. So the next, I'll give a quick walkthrough on our code structure. We have all our service-related stuffs and service-related scripts and sample images are under the app folder. And we also provide certain command line utilities for prediction and for training purposes. All the command line utilities will be inside our command folder. And yeah, so we can see the command line utilities, everything. And the data structure, all the training data set, test data set will be inside the data folder. And all our deployment related is there inside the Docker folder. And on our core pipeline related works are under the folder called Mystic. We name internally pick to card as Mystic. So all our, we can see the model prediction flow, all the training configurations and all the layout generation work have been modularized and kept inside this folder. And we also provide notebooks for playground, for sample testing and all. We have notebooks for different models, for different notebooks we do have. And our core model, the faster RCNN trained model is available inside the model folder. This trained model that we use is there inside the model folder. Basic understanding of our code structure. Maybe I'll give it to Vasant on saying how to contribute to pick to card.
So the pick to card has become our playground, and then we had a lot of fun with it, playing around with a lot of different models, trying out different things because it's really encouraging. And then the output, what we have seen, right? It is really you guys have seen that the power of pick to card. So it is really encouraging for us to try out something like this, and then we really loved it. And then it has been like almost like 6 to 8 months of project. We have been trying out with the different data source, different ML models. We have been trying out with the different data sets, and then we compare ourselves how we can constantly improve on it. Okay, we love the code. We encourage everybody who want to contribute towards this. Right, there are multiple ways of contributing. Take a look at the source code. You can file a bug, or if you like extend this to support other cards or other elements, you can do that. You can fork it and then raise a PR. We are happy to review it and then merge it part of our source code. Or for if you find a good bug or if you find an issue, please share with us. We'll definitely fix it. Okay, you can raise it as part of the GitHub issue tab. So yeah, there are great ways to contribute. So what is there in our roadmap? So immediately we are going to hit the production. Probably you can expect in a week time. This is there in the production as part of the designer, adaptive card designer. So after we release, we already made a lot of improvement from what is there currently. So we are quickly going to release some of the new layout generator, which is going to improve even from what we have shown today. And then it is going to improve all the alignments and then font, understanding the font better, right? Because when we upload a image, we want to create the adaptive card as close as the pixel perfect as the image. That is what we are trying to do here. And then we are also going to provide a way the user can give the feedback, like if there is a bug or if they want to comment or if they want to recommend something for us, we can definitely do that. Also, you guys can upload some of your beautiful design. If it is a free design and then you guys like to share the design so that we can improve the ML pipeline, definitely we welcome you to do that. We will quickly give the interface so that you guys can share the design. Okay? And then the model, whatever we have built, it's a reinforced learning. So it is going to learn from whatever is going to getting uploaded. So it is going to keep on learning, and then it is going to keep on better itself. And then we are working very aggressively, and then we will fix any loose ends or any bugs which is already there. And we are also committed to support any new element which is going to come. For example, we already started supporting the star rating button, which is going to come in the new adaptive card 2.0. So like that, any new element which comes to adaptive card, we are going to support, take that and support as part of the pick to card as well.
Yeah. Cool. Yeah, super cool to see. Sorry, I'll let you kind of finish. I did have some thoughts on that, but I'll let you. I want you to finish.
Sure. So this is a kind of like last slide before my Q&A. So I want to take a moment to give credits and who are the contributor, the major contributor for this, right? So we have Pick to Card on the right-hand side. We have Keetana, Haridas, who's spoken with us. Other people like Dava, Amit, myself has contributed towards this project. We are also one of the active contributors. We are completely own the React Native renderer for Adaptive Card. These are the people who did the contribution. Probably one other community call will present that as well. It is also available as open source. Please take a look and then give us the feedback over there. Over to you, Matt. I'm happy to take any question from the crowd as well. Yeah.
Yeah, super cool. So yeah, so definitely let's we can take any questions. I have a couple just to kick it off, but yeah, feel free to either click the hand raise. I tried to help people along in chat as it went, and some other folks from Imaginea were chiming in as well. But one question I had, so there was an image I had. I guess like one is out of practicality. So I found an image on the internet. I think it was a card from Facebook Messenger. And it came out about like 90% good. I think I kind of emailed you some of the details on what I think I would expect differently. So what tactical steps are we going to take to minimize that feedback loop between someone tries an image, they see some things, what's our approach going to be for how do we actually get feedback where if people see something they didn't expect, and then how do they file that?
Okay, so as of today, if you see it, we have only, I won't say minimal, we have a decent amount of data set. We have roughly around 200 different design, right? 200 different design of the adaptive card. So as the data set grows, the model is going to outperform, like it's going to improve itself because we have built a reinforced model. We can definitely input the whole image and then that is going to keep learning from it. So that is one way, definitely the model is going to learn and then it's going to improve itself. And then we will provide an interface wherein which people who like to contribute to us, they think that, okay, this is a great way of creating the adaptive card. We'll give an interface which will allow them to upload their image or give them the feedback if they find that 90% was working. And then for example, there is an element which it is not detecting perfectly. They can quickly crop and then upload or give us the comment. In that way that we will take care of it. We will input that as part of the machine learning algorithm or as part of the model itself, so that it will learn from the mistake and then it will betterment itself.
Yeah, and so this is totally just out of curiosity because I definitely, this is an area I am so not up to speed on. All the machine learning, neural network stuff. Definitely found it super interesting, but was definitely outside of my wheelhouse. So out of like total curiosity, as the one example, I was trying to find the image, but it was like a restaurant card, very similar to the one you showed. And the image along the top was at a cafe, but it kind of had a dark shadow in the middle. Mm-hmm. And so what happened when I uploaded it through Pictocard is it split those into two images. It interpreted them as two separate images because that divider kind of, so at a super high level, explain it to me like I really don't know what I'm talking about because I don't. Like, right. How would you address something like that?
Okay, so probably the reason why it detected as a two different image is our machine learning algorithm, the input what we are given, it has not seen a similar kind of image. I'm not telling dictative card. If it, for example, if there is like we are trained the whole image with a lot of background noise and then background shadows, it will try to classify itself. Okay, it will understand, the model itself will understand that, okay, this is a shadow, this is like the noise which it needs to remove, right? It needs to remove during the output. So we have to input, we have to enhance our training data set, and then we have to input these kind of images so that it can do better. That is one approach. We are also doing denoising. When we take the image, even though we show the pipeline, there is a lot of other work which actually happens. So when we take the image, we do kind of like clearing it, denoising it, right? So we can definitely improve in that part, and then it is going to better itself. Yeah.
Cool. Awesome. Thanks. Yeah. So yeah, any other questions from folks? The key thing, people ask about when can we get it in the source code. So that's kind of critical. If you can put that other slide back up just real quick. So the source is, we walked through it, and then hopefully, I always hate to promise timelines because who knows what happens. But we are we think we have a good idea of what the accessibility stuff is. I think we're all fixed. We're just waiting on final sign off. So I think it's pretty highly likelihood that this will be available on adaptivecards.io this month. I'm hoping that's a pretty reasonable thing to say. And then, yeah, what's kind of exciting to me is then, just like you guys are saying, the more people that use it, the better it'll get over time. And that is just fantastic.
Right. I think that's all we have for the day. And thanks, Matt. Thanks for inviting us for this great show. And then I hope everybody likes it. And then it's a little magical, right? So I want everybody to just try it out, give us the feedback. We'll keep on improving, and then it's going to ease out, and then it is going to make the whole design experience itself into a different level.
Yeah, for sure. And I'll take a second. So if you, I know it's late where you are, so feel free to jump off if you need. I will go through the questions real quick. I think there were some kind of unrelated ones that I'll just go through in the chat. So what's the best way to find out progress on issues? I was trying to paste. I don't know what the heck happened to my chat. aka.ms/AC roadmap for the latest features. So AC roadmap is where you're going to want to go to see what's in development. Stay tuned to that launched tab. That's anything we've recently launched. And once this goes to production, you'll find the Pictocard announcement right there. So that's a good way to track features. As far as bugs, though, I think there was a comment on input.number not accepting floats or something possibly more bug level or minor feature requests. That's going to be tracked on our GitHub. And I kind of lost that question. But basically, yeah, the GitHub is where really you're going to find a lot of that stuff. So hopefully that helps. And Power Virtual Agents, thanks Tomasz for answering that one. Really excited for the opportunity to get adaptive cards in the hand of more Power Platform developers with Power Virtual Agents. So we'll keep working with them and unlocking them, whatever they have, and hopefully we'll get that out to you. And then Shalini, thank you for helping answer the question on when we're going to get Microsoft Teams updated to the latest. Maybe there was nothing else. Lots of discussion on the different machine learning algorithms back in the beginning. All right, perfect. And then it looks like one person said they have a question potentially coming, one query. Okay, apparently of launching an API. I assume that's asking for maybe the Imaginea folks. Okay, yeah. So is there an API that they could use to programmatically access this? And I want to preface that answer with, even if there is, do we want to encourage it? Because I think Microsoft is currently footing the bill for that service, and I don't honestly know how expensive it is.
So the source code is available. Even we archive the model, and then we are saving it as a part of the source code. So you can create a quick Lambda function and then expose it. It's not going to cost you much. So it's not the entire machine learning is going to run, right? You can just deploy the model and then expose a simple API. It's as a simple Lambda function, right?
Yeah, that's a great call out. And is that currently like, is that documented in the Pictocard README at all? Like the self-hosting stuff that we can just say, hey, like, look, if you want to self-host this service and yes, you know, put it into your own website. Like, so a lot of people embed the adaptive card designer. A lot of our partners have embedded the card designer to make it closer to their workflow. And I can imagine them wanting this functionality in their own products as well. Embed the designer, enable the Pictocard support. And I know you've built that into the code where you can just point it to the service URL. So they would take the code, deploy it to either an Azure function or any kind of, any kind of cloud provider, really point to that endpoint, and then they would get that integration all on their own. Is that fair to say?
Yes, we have exposed as a Docker, so which is a machine independent code, right? You can deploy the Docker in any cloud and then expose as a Lambda or a quick function, and then you can write API on top of it. It should be simple and straightforward.
Perfect. And yeah, any thoughts on that? Reach out to these folks on GitHub. They're just as active as us Microsoft folks on that GitHub. It has been such a cool. It's been for me the most open source project in the true spirit of it that I've ever worked on. We're getting to work with a kind of wide array of folks. In this case, with vastly different expertise than I have. So that's very cool. So one question from Ryan. So is there work in progress that allow components of adaptive cards to be tappable, clickable other than buttons? So Ryan, I think that's actually possible today. You can use select action either on columns or images. So that might, and I can try and find the docs for that real quick, if that's what you mean.
Right. It works on button. It works on action set. You can have a radio button, checkbox, everything. So everything it works as clickable. So as of today, it works.
Cool. Well, very nice work, everyone. Thanks, everyone, for jumping on the call. We'll see you in a couple weeks. December 10th is the next call, second Thursday of every month, 9 a.m. PST. Thanks for an engaging chat. I Imaginea folks, Vasanth, Haridas, let me make sure I got her name right. Sorry. Need to find it through. Oh, I apologize. I'm messing people's names up. Thank you so much for jumping on and contributing this and sharing it with folks and working with us to get it rolled out to production. We'll wrap this up here and we'll see y'all hopefully in December for the next community call.
Sure, Matt. Thanks you and then David for all the support and then all the good work. Right. It's great working with you guys as well. Thanks everyone.
All right. Thanks everyone. Bye bye.